you want to start us off, Pepe?
Welcome, everyone. Good afternoon. I am Pei Ping from the Training, Recruitment, and Mentoring Working Group of the Bridge Center at UCLA. On behalf of Dr. Carol Watson, we thank you all for joining us on this important lecture from the Voyage Bridge2AI team as part of the TRM Learning Resource Grand Challenge Datasets module.
And I'm Jack Rincon, TRM Working Group Project Manager, and it's my pleasure to host this session and introduce the next Bridge2AI Grand Challenge lecturers from GC Voice.
Thank you, Jack. As a brief reminder, this particular education module provides insights into all data sets across Bridge2AI Consortium from its partnering Grand Challenge projects. The TRM working group's goal with this module is to prepare our consortium investigators as well as the public in our scientific community to engage with Bridge2AI Consortium AI-ready datasets, understanding both the structure and the potential applications of all datasets generated by Bridge2AI.
Yeah, thank you, Pepe. The focus of today's lecture is on the Precision Public Health Grand Challenge, or Voice project, and its role in creating an ethically sourced multi-institutional voice database linked to diverse health biomarkers to advance AI-based predictive models for disease screening and diagnoses. They collect data via secure apps connected to EHR and biomarkers like radiomics and genomics, focusing on 5 disease categories where voice changes indicate specific conditions.
Today's lecture, we're honored to feature Professor Yael Bensoussan, a world-renowned leading physician on voice disorders. She also heads the Bridge2AI Voice Data Generation projects. As principal investigator, she leads the efforts to harness voice as a biometric tool for early disease detection using AI. Her team is world-renowned, developing voice-based biomarkers aimed at diagnosing conditions like respiratory and neurological diseases, as well as mental health issues, with great potential transforming global patient care and public health.
Also presenting today is Dr. David Dorr, a global leader in health informatics from Oregon Health and Science University, and who is also the team lead for the Bridge2AI Voice project. With a focus on data integration and precision health, he leverages his expertise in informatics to drive the project's mission of using voice as a diagnostic tool. His work aims to make healthcare systems more efficient, precise, and responsive to public health needs.
With this lecture, we hope you will gain an understanding of the mission and scientific goals of the Voice Grand Challenge, learn about their datasets creation and protocols, their unique ethical considerations, and explore opportunities for collaboration within the Bridge2AI consortium and beyond in the broader scientific community. With that, I'm going to hand this over to Yael and David, our esteemed speakers.
Thank you guys so much for this very kind introduction, and thank you for having us today. We're very excited to share what we're doing. So I think my slides are working. Right, Jack, you can see my slide?
Yep, looking good.
Perfect. Okay, wonderful. So we are the voice DGP within the Bridge2AI program, and right now voice biomarkers are very cool. There are talked about in the media. A lot of industry partners are talking about them, so much that the market is estimated to reach almost $10 billion by 2034. the interesting part is that there's a lot of ethical considerations for this digital biomarker compared to other biomarkers, because obviously now there's technology allowing us to clone voices, and people are scared because now they're getting calls from their children asking them for money when it's not really them. So with deep fakes and voice cloning. So just a few definitions before we start. We talk about voice biomarkers, but really that definition includes voice and speech and linguistics. To produce sound, you have to be able to voice, so your vocal cords have to come together. When we talk about the voice, it's really the quality of that vocal cord vibration, versus speech has a lot more information. So you need to breathe, you need to articulate the words. There's a lot of content in the words. So you'll have different biomarkers in speech. So I always say birds can voice, but they cannot speak. And then artificial intelligence, I think you guys are all familiar with it. There's a lot of current challenges in voice AI research, and most of the research out there is great. We're not the first ones doing voice AI research. A lot of people have been doing voice AI research for probably 20 to 30 years. But the issue with the current data sets out there is that they're small, that there's really a lack of diversity. Usually it's single institution, and we know that voice is really important. There's a lack of standards on how we collect the voice data. And there's also a lack of understanding of the impact of different languages and accents on voice biomarkers. Because it's hard to do and to study, because voice can be considered a HIPAA identifier in a lot of different institutions. We're going to talk about that today. And overall, there was just a lack of big infrastructure to be able to collect voices in a way that's efficient, and that allows us to build large databases. And that's really all the challenges that our DGP is hoping to answer. As you can see, these are just probably a tenth of the different startups and industry partners that are involved in voice biomarkers. And I would say that every month there's a new stakeholder, a new startup that focuses their products on voice biomarkers. The problem is, although there are all these startups out there and all these players out there, voice biomarkers are not completely integrated into clinical care. I'm a clinician, so I'm actually a voice doctor, and I assess voices for a living. And I can tell you that no one in our field is actually using these biomarkers in an everyday setting. The big change this year is that there's ambient devices, so AI scribes that are taking the market, and they are recording you when you go to the doctor to help the doctor summarize what you're saying. But really the future of voice biomarkers will be to integrate these voice biomarkers in these ambient scribes, so that not only these ambient scribes can summarize what you're saying to the doctor, but also at the end of your encounter say, oh, this patient is at a risk for Parkinson based on the voice biomarkers we screened for. So that's why there's a huge potential for voice biomarkers, and more than ever, we really need public databases to be able to understand them, for researchers to have access to them, to validate the algorithms they're developing privately. We need privacy standards to protect patients in this very, very rapidly evolving world of technology. We need acoustic standards on what are the expected quality of the recordings to be accurate. And we need open access tools to help people analyze this data. So this brings us to the goals of our DGP, which is to build an ethically sourced, diverse, and AI-ready database of 10,000 human voices linked to health information from 5 categories of diseases that we'll discuss. And really, in terms of what's out there in data sets, usually the best you'll get is, bimodal, where you'll have voice and then the diagnosis. There's really no data sets out there that incorporate multiple clinical health information on these patients. And we're really trying to build something a lot more thorough. And that's our primary aim. But as a group, we also have secondary goals that are sometimes as important. Our goal is to build a network of stakeholders invested in voice biomarkers, because we really believe that that's the only way we'll make a big change. To develop standards of acoustic data for voice AI research on how to collect and how to share, to develop the tech infrastructure, the ethical guidelines, and then most importantly, to teach the next generation on how to use that data set properly, so all our efforts actually bring more impact. These are currently the categories of diseases that we're studying. So mood disorders, cardiorespiratory disorders, voice disorders, neurological disorders, and pediatric disorders. And to give you a few examples, there's a lot of work, for example, being done in COPD. So how to diagnose COPD based on cough or respiration. If you look at mood disorders, lots of work being done in depression, anxiety, and how to screen people earlier or even see how bad they deteriorate. In terms of what we study, we collect raw acoustic data, but we also extract a lot of information from the raw acoustic data that we're going to talk about. So we analyze speech, voice, and we also analyze breathing sound and collect breathing sounds, which is quite important. We have a huge and amazing team of leads from different backgrounds. So from teachers, educators, ethicists, clinicians, AI, ML scientists, acoustic experts, and engineer. And we have over 50 investigators across 15 different institutions in Canada and the United States. So this is our team. And according to the Bridge2AI pillars, we go off of 3 different pillars. So the data is important, but we learned that without the ethics of it, our data can be useless. And that's why developing appropriate consent protocols, data sharing protocol will prevent us from being shut down as a program, for example. Really important to have patient privacy in mind. And then the people, including the people who will use that data and that we have to train. So a little bit about how our data is collected. So that all the data that we collect is what we call prospective clinical data. So that means patients are coming in and we collect data from scratch. It's all done through consent. So patients have to consent to sharing their voice data, and it's collected through an app that was developed from scratch by our Bridge2AI team. We'll show you a little example. All the protocols for data acquisition were informed by an expert consensus. It actually took us 6 months to develop the protocol because there was so many different protocols available of what tasks we had to collect in different types of diseases. And it was really important to bring all the community to understand what should be collected. And then our protocol for acoustic standards, so how we collect from an acoustic perspective, is evidence-based. We have a large team that conducted a lot of experiments in the lab and outside of the lab for the first year to realize what acoustic information is important and what acoustic quality is important. This is an example of our app. So this is the app that we used in clinic to collect voices. And then you could see the app has the IT infrastructure that brings all our sites for data collection together, but also the privacy that only people from a specific site can have access to their patient. On the app, you can do all of the tasks, but also the clinician can provide the diagnosis and can choose different tasks. There's audio checks, and we'll look at what else we can do in the app. Always interesting to see how it's important to optimize and to test in real life the technology we develop. This was a feasibility study we conducted in the first few months of our app. And we realized that 80% of patients were not pressing on record when recording tasks, and they had to be instructed to do so verbally. So we learn a lot continuously by trial and errors and feasibility study with our patients. And it's really important to be adaptable in the technology we developed. We know, for example, during COVID that there was a lot of companies out there that were collecting cough for COVID. And one of the famous article reports that they collected 40,000 patients, and they had to throw out 35,000 because the data was not usable for different reasons. So really important for the data to be accurate, AI ready, and analyzable. Currently, we are at 412, well, probably now we're at about 500 participants. That's our app in numbers. It gives you the amount of, although it's a low number of participants, you could see that the number of acoustic tasks is huge. The number of recordings is even larger, and the files are even larger. So what's really rich in our protocol is that every patient donates about 1 hour of time and of voice data collection. So there's a lot of information in that, and each patient's protocol is very rich in information. We have a dashboard that will be publicly available next week that gives you an idea of the distribution of diseases by diagnostic group, by age, by demographic, by specific socio-demographic as well. And that's going to be available for anybody who wants to use our data set and live in terms of accessibility. And then what specific data do we collect? So we get that question a lot. A lot of these voice data sets that exist out there will only have, people reading a specific passage. And in our data set, we collect a lot of data. So we collect 22 bioacoustic tasks that I'll describe for you. We collect very extensive demographics and confounders, because these are really important. We know that demographics and confounders have a huge impact on voice, right? So a 30-year-old female that lives in Florida, not 30, but a little older, will be a very different voice than a 75-year-old male who lives in Arizona, for example, and whose primary language is Spanish. And it's very important not only to collect, but to make sure that we have a diversity of voices in that sense, and to report that because we need to find voice biomarkers that are transferable in different languages and that account for these confounders. Confounders like smoking history, drugs, alcohol, but also fatigue. We know that fatigue has a huge effect on voice hydration status as well. And then we collect a lot of validated questionnaires. So why are validated questionnaires so important? We'll talk about how we validate our data with clinical validation. But at the end of the day, clinicians who validate diagnosis can be wrong, or some of the things can be subjective. So we do have validated questionnaires that the patients complete. So we call them patient-reported outcomes, where that can also become a gold truth when you use AI algorithms. For example, MoCA, which assesses the cognitive function of somebody and is used broadly in cognitive research, is completed for each patient. And then that could be used as a gold truth as well when you analyze this data using AI. We collect imaging data, including CT scans, MRI, laryngoscopy, and we have a cohort that has whole genome sequencing. We can't do it for everyone because it's so expensive, but there's a cohort of neurological disorders that's piloting genomic data as well. And why do we collect so much information in voice? Specifically because most people will have a lot more than one diagnosis. And that's really the problem with other data sets out there, where they just say, well, let's do a study on Parkinson. We'll take people with Parkinson, and the control group is going to be 30-year-old healthy males. And the inclusion criteria, you have to have Parkinson only. If you have anything other than that, that is impacting voice, you're excluded from the study. And that's the problem, where our data sets that we had access to really can't be generalizable. The results that we have are not generalizable. So for example, this is an example of one of our patients, a 63-year-old male, has a history of base of tongue cancer, had radiation, primary language is French, he's depressed, and his wife tells you that he can be quite forgetful sometimes. So he has all these different confounders and comorbidities that are affecting his voice, and it's really important to collect all of them. That's my favorite sentence. I always say real life doesn't have any exclusion criteria. So we try to have the least exclusion criteria as possible in our data set. This is our clinical validation data. So every single patient is assessed by a physician that then will correlate and confirm all the diagnosis in the app as well, to have a gold truth for analysis. This is a list of all the acoustic tasks that we collect. So there's 22 of them, and it goes from respiration, coughing, breathing, to voice sounds. So like a prolonged E to see how long you can say E for. And then validated passages where people have to read, and then open free speech questions to assess also the content of the speech. Oh, that's me breathing. Okay. And then the data set contains for some, we'll talk about the ethical and the access and the tiered access. But we collect raw audio data, but we also convert it into waveform data, Mel spectrogram, transcripts, and extracted acoustic features. And these data formats that are transforms are really important in terms of ethical sharing that we'll talk about. Okay, and then the other last thing I think is to talk about the data bundles. So to be able to compare and that each patient can become a control for another patient, we do have a common protocol for all diseases where all patients are doing the same protocol. So for example, a patient that comes in with a depression also does the questions for neurological disorders because maybe he has a beginning of Alzheimer's that was not diagnosed, and that's really important for our study. A cool thing we do in the app is what we call gain adjustments. So obviously really important when you record, for example, Lady Gaga, when she sings too high, she has to take the microphone away, or else there's something that we call distortion or audio clipping, and that has to do with the quality of the audio data. So a lot of work has been done to do inside the app gain adjustment to be able to account for that and for the loudness. And then, David, do you want to start on the ethical implications?
Sure, I'd be happy to. Thanks. Yeah, also, if you go to the next slide. Sorry. So, excuse me. So as we all know, for de-identification of data sets, there's actually two standards, one of which is these safe harbor identifiers in HIPAA. And number 16 here is biometric identifiers, which includes voice prints. So voice is actually an identifiable feature in safe harbor. And so releasing raw voice prints is a significant issue. If you go to the next slide, oh no, go back, thanks. So the second part of this that I think is really important because we are in sort of a gray space here in terms of de-identification is, there's safe harbor identifiers, which are like, what is a voice print, what actually defines that, versus the sort of statistical the statistical re-identification rules under HIPAA, right? And those are, how likely is it? What is the risk of re-identification with these? And this is really where a lot of our tiered ethical our tiered release structure sits in sort of this increasing concern about risk of re-identification or the ability to identify has tighter controls. But as part of this, as part of our effort here, we wanted to make sure that we could release data more broadly. And so we have this sort of tiered approach. If you go to the next slide.
Almost there. There we go.
So, it's funny because there is really so much voice data out there already that's everywhere, and we've already seen a large number of abuses with that, including the ability to voice clone with very small amounts of raw voice data. And in this, this is sort of our ethical, dilemma here is exactly how do we keep these keep our consented patients, our trust from those communities safe, especially for people who do have certain conditions, but still allow people to get access. So if you go to the next slide. So because there are many different data elements here, some of the issues that we also have is that we have tasks that have people just speak freely, right? They're just open questions. They can respond however they want. And we also, and so what is in those really has to be scrutinized, because even the text from those sometimes can contain identifiers alone, as well as the voice spectrograms, which Yael talked a little bit earlier, have some risk of being re-identified or brought back to the original speech. So, um, you know, again, although the goal is to be as open as possible here, we also, felt that the risk of these spectrograms related to purely free speech were too high, and we're exploring that. I don't know if you have an update on that, Yale, or is that
Yeah,
still?
yeah,
Yeah,
so it's interesting, right? So right now, because MIT developed and other people have developed tools to convert back spectrograms into voice, you can, even if you give spectrograms, technically somebody who would be malintentioned could convert it back into voice. And sometimes when people answer questions, they'll say like, "Hey, I'm happy, but I went to see Dr. Bensoussan on this day," and can provide re-identifying information. So our team is working on two different things. One is we have to now manually remove these patients. And then obviously there's different technology available to use technology to remove them. So for this data release, we were able to manually remove all the questions that included identifying information.
great. Thanks. So, how do we make this determination? And those of you like I who've worked extensively with research ethics boards and institutional review boards uh, know that this is really an ongoing discussion, right? And that is what's important to us. Um, in in many respects, because HIPAA came out more almost 30 years ago now. I am old. Um, that that these new technologies are really not built into the law, and so there's been a lot of new determinations and precedent in here, and that IRBs are rapidly trying to update to get more information about the impacts of artificial intelligence and some of these new kinds of data and data sharing expectations. So I think, often in my role as Chief Research Information Officer here at OHSU, I think about what are the balances between having this open ecosystem with data sharing that can contribute knowledge, but also better quantify these risks versus these risks of re-identifications, and the technology to process these data, the type of data, um, overall. And so we've really been, we have an incredible ethics core, and I think we've really been advancing through these issues overall to try and balance this. Bridge2AI also has sort of an amazing set of lectures around the ethics that I would encourage people to go back and look at in the archives. If you go to the next slide.
And if you don't mind, David, I'll just
Yeah,
add something
please.
about the program. What's interesting is that the common rule says that the context is important on how the data will be used. But the goal of the Bridge2AI program is to develop data sets that are hypothesis agnostic for people to use downstream, and we can control how people will use it. So that's really the hard part. And we've had to deal with that. For example, I can give a concrete example at Sick Kids, where we collect voices of kids, and obviously they're a lot more protective than their adult patients. And the IRBs asked us, well, how are you going to analyze the data? Will you use AI to analyze the data? I said, yes, probably other people will. But then they said, well, we need to know every use of the data possible, which is not working for open data sets, right? So that's one of the many challenges that we have to think about, is how to predict use, how to create a data set that's opened enough for people to be able to have to be free to use it as they want to make discoveries and not limit the discoveries, but also abide to these new laws where institutions are scared, right? And they want to be able to limit the types of use.
Yeah, and that's great. So these are the three tiers I think that we can really walk you through. And so at the left-hand side here is sort of an interface where you are able to register. These are non-identifying and non-sensitive data. And really, it's sort of an attestation. We know who you are. You sign a license overall, and these are some of the characteristics like jitter here, some of these key elements. And what goes in this set, as Yael was saying, is evolving and over time, but is intended to not be identifiable. And then the next stage up is a controlled access with some reviews. That's, non-identifying, but still has some sensitivity in terms of, the concerns about its re-identification and, the uses to which it could be put. In which case, people actually, do those same three steps of registering and doing an attestation and license, but then go through an access committee and sign a data use agreement for those specific uses. So we know a little bit more about the uses, and then we have that agreement, which is quite common now, even among fully de-identified data, where I should not say that, where the data is as de-identified as possible, but there still remains some risk of re-identification. And then the identifying data, these really kind of purely identifiable is through sort of, essentially becoming part of the broader research team, which is, I think part of the goal. So research teams with IRBs and those kinds of agreements as part of that still available. I think we shouldn't see this as an incredible barrier, but in terms of really being cautious about the uses and having these process in place will be important, and a similar approach in terms of onboarding and sort of this review. Is that a good summary? Yeah, would you add anything?
No, that's very good.
Right.
We're trying to be more conservative to start with. We may, this may become more and more accessible, but we don't want to make a mistake and then obviously have somebody re-identified early.
Yeah, that's right. Once it's out there, it's out there. So let's talk about some of the use cases. And I think also, the release of our data, that's one of the requests that you had for us all. When will that occur? And it's by the end of this month, is that right, Yael? There'll be more information. So we would be happy to share back with the interested group. So one of the goals of this project, and I came onto this in terms of really focus on, the training, part of it, is really to try and get this kind of data into clinical care because it's so useful, because we perceive it so useful. The evidence about its use is sort of amazing. And Yael's a voice doctor, right? So in her work, she sees, her and her clinical team see immediately, oh, this could help so much in diagnosing and understanding trajectory of illnesses and potentially even helping guide treatments and certainly for the other areas. But to do that, we really have to create this virtuous learning cycle where we get that data out there and then get people to use it, build the algorithms, get people to use it, demonstrate that it improves outcomes, that it helps with efficiency. That's the other part of this in a lot of AI, and that there's the necessary approvals and scientific evidence so that people then could get paid for it and continue to use and improve it. And I think that is really the goal. So for us, a lot of our partnering and use cases is trying to build this virtuous learning cycle. If you go to the next slide. As well, there is a lot of, voice is such an interesting element because it is so personal, right? And the algorithms can be applied. A person can generate their own data in essence, as they're doing with our trial, but with an AI. And how do we sort of help with that? And the first and most important issue is trust, right? And I think there are so many examples out there already of these algorithms in use where we don't really know whether to trust them or not. So we really have to think pretty hard about how we keep that trust and help to create this kind of cycle where the ethical and regulatory frameworks are very focused on the people and how they might use it, and then how it can be cost effective, who pays for it if it's direct to consumer, and then in terms of ease of use, right? Because people won't have sort of the other context in place, and how do we make sure that they're getting good information, which I think Yael's and team have done an exceptional job of sort of setting some acoustic standards, and building an app around collection that is really one of the best that I've seen. So if you go to the next slide. Speaking of which, there's a couple of papers out here in the Journal of Voice and the Journal of Speech, Language, and Hearing Research that really goes through from very sophisticated acoustic environments with high fidelity microphones all the way down to your smartphone, and really lays out what are the standards for people to record. And so one of the things we want to offer is, if you want to do your own voice research and bring people on, we have this protocol that we're very happy to share. And we have these standards for how they could be set up, and what kind of variation there are. And that is so important. So, who would use these and for what reason? The things we think about are diseases like Parkinson's, where speech production and sort of all the way through the ability to produce sounds has really changed, as well as speech production in Alzheimer's, where you have delay in speech and effects on language, as well as respiratory and vocal cord related issues as well. And so we really want this to be a benchmark data set, as well, for quote unquote normal voices, which is sort of a difficult term, but at least people with and without certain kinds of conditions, as well as for consideration for moving products through this regulatory framework. So, for industry and pharma, if they want to be using these kinds of tools in their work, and even potentially considering moving it through the FDA, which is a whole different set of things. So lots of users. I think what we've learned so far, I mentioned the acoustic standards and the data quality and ability to sort of do, have a tool that sort of allows you to adjust and is easy to use. So we have a lot about that. We have a large number of papers that came out already. Some are listed here about this validation, the ethics from stakeholders, and we have a voice symposium we'll mention as well, and then a lot of the processing information. So really, to know how to work with this kind of data, you have to know how to work with waveforms, or understand when you get spectrograms or results of earlier analytic processes, how you got there, and what the differences might be. So that requires some very specific training. If you go to the next slide. So that is one thing that our group sort of focus on. The other thing we are really focused on are these partnerships, because there's so much interest in industry and others that we have partnered internationally. As you may hear from Yael, she's a person with a lot of connections in Canada and Europe, as well as the rest of our team. So CoLive Voice is based in Luxembourg. That does something similar to what we're trying to do, a little more focused on diabetes. We've worked with the Alzheimer's Disease Foundation, so really trying to augment the data set, and we're very open to that. Aim Ahead, which I know most of you know, that works with training historically underrepresented learners and non-research organizations to try and build up AI readiness and capacity. And then we have this symposium that we'll mention in a second, and invite people to come. It's an amazing opportunity. And then we also ran a summer school that we'll talk very briefly about. Go to the next one. So the Voice AI Advisory Board is from all different groups, industry. There's a lot of nonprofits that focus in this area because your voice is sort of so personal to you as you start to lose your ability to produce voice. It's so important. And so we have patients, we have the nonprofits and their advocacy groups, but also industry is very interested in this. They're an amazing group. And I think Gail's done a very good job of working with them and getting input. And our hope is that they will carry this mission further through their organizations and into other places. So that's one of our key goals. If you go to the next slide. We also have a website, very easy to find if you search on Bridge2AI Voice, and also on the main Bridge2AI website, you can find all kinds of videos and information and really learn about our challenges. Go to the next slide. And then the Voice Symposium. So this was an amazing experience in 2024. We had 162 attendees from all over, including as far as Australia. And we really focus on it's a combination of there's some interactive learning about the aspects of voice. There's workshops and panels where we're really talking about advancing voice as a biomarker, about sharing data, about sharing research. And so we really do invite you to come. And then we have published that in the Frontiers and enabled people to connect. And then for our summer school, last year, we were able to have 5 weeks of a hybrid program at 4 different sites with 50 trainees that culminated in an in-person session with a hackathon, really getting the hands on the data. And for our experience, that's crucial. Here's some examples of this. The trainees were clinical trainees and data science trainees, so which was a very effective way of doing this because it's a team-based effort. And here's some examples of some of the trainees. Go to the next slide. So here are the use cases that we had, very simple ones, really, which came from the same speakers. Can you do smoking status? Can you differentiate between different kinds of respiration? Can you detect socioeconomic status? And these are the kinds of things that we think people should be trained how to do as then they develop these much more advanced models. If you go to the next slide. So these are our, and we can share these links for people, but these are our 2 links. We're asking for people to submit abstracts for this year's Voice AI Symposium that will be at the end of April in 2025, and to register. So please do come. So I'll let Yael have the last word.
Yeah, that's my favorite slide. I mean, what we've really learned in this experience is that it's so much harder to build something as a group, right? It's always easier to build something on your own, but the impact that you can have as a group of such diverse people coming together to really change the field is a lot more impactful than individual working independently, in our opinion, and we've really enjoyed the process.
Yeah. Yeah, and it's been great. And again, if you want to find anything about data release and how to get access to this, it all gets updated on both the main Bridge2AI website and then our local website, and you can go through that process. And in about a week or 2, there'll be lots of open opportunities there to start to engage. And we actually hope to have the summer school again. So we will also make announcements about that.
Thank you all so much, Professor Bensoussan and Professor David Dorr. We do have one question in the Q&A. I'm going to hand it over to Jack.
Thank you. That was an awesome presentation. And I do look forward to follow-up lectures from you guys to learn more about the GC. We have a question from Stephen Swee. It goes, it was mentioned that waveforms could be used as features for an AI model. Would explainability of an AI model come from highlighting which waveforms were used to predict or classify a disease? If so, how would knowing these waveforms themselves be useful for physicians?
I'm going to try to answer this one if I understand the question correctly. But so we talked about transforms, and there's waveforms, but there's also spectrograms and acoustic data. In a lot of published paper out there, people have actually traditionally used just extracted acoustic features. And you're correct that sometimes it provides really interesting results without explainability. So for example, one of the very famous paper on Parkinson's and voice biomarkers in Parkinson found that the feature extracted that was significant was jitter. For people who don't know, jitter is basically how variable your voice is. It's used in acoustic research. Should not have too much to do with Parkinson's. So sometimes there's this gap between, what data scientists find and explainability of AI models. And that's why we think that our data set is best used with a lot of training to be able to talk about that explainability of the models. And also that's why we also want people to have the opportunity to access raw data if necessary. And that's really what we found that was useful in our training summer school. The students that had the best projects, papers at the hackathons were the one who truly understood the different features. So even if they were working with spectrograms, when they looked back on what type of data it was, they could have good hypotheses in terms of explainabilities of the models. Does that make sense?
Thank you for answering that question. I think we do have one more question. How long do you think more or less it would take for there to be a really solid, like standardized protocol for voice data sets?
Yeah, so we're actually working on an international protocol, Delphi Consensus. And a lot of what our team has been doing for the last 3 years now is work on specific aspects of these protocols. So, one is how do we collect it acoustically? So our team has done a lot of work for that, right? The other one is, well, what questions do we ask the patient? And our approach to that was to ask all the questions and then analyze which ones are more pertinent. There's the ethical standards. There's which features do you use for which different diseases. And after 3 years of doing all these parts, we're actually now working this year on international protocol, which is really kind of a recipe of how to develop a voice biomarker. And we are hoping to have results drafted or completed by the end of the year, at the end of the academic year, which is in July, and hopefully released a few months later. And that's really going to be based on not only our standards, but a group of stakeholders that is outside of the Bridge2AI group. So hopefully a year to year and a half.
I will say the current protocol is pretty excellent. There's more thought that's gone into it than almost anything else. We're happy to share that as well.
That's a remarkable progress, Dr. Bensoussan, as we all know how challenging and complex these data sets are. But as both of you have shared with our audience, this is an exciting new field that has so much potential and applications in multiple disease domains. And you may have been shared that the Bridge2AI videos and lectures will be on a YouTube channel by Bridge2AI Consortium. So I'm sure in addition to the many scientific communities we will be sharing your videos with, you would also receive input from many audience that access this from the YouTube channel of Bridge2AI. And again, I want to thank you both very much for taking your time and to introduce to our audience your data sets. Jack, back to you.
Yes, thank you so much, Dr. Bensoussan and Dr. David Dorr. At this point, we don't seem to have any more questions, and we could end the session here if you guys are okay with that, unless you guys have some final thoughts to share.
Yeah, of course. Nope. Thank you so much for inviting us, and we're excited to hear more from everyone. Thank you.